Welcome back to the Tech Civil Learning. My dear friends, I promised you just give me your 20 to 30 minutes time. You'll surely going to understand the concept which is mentioned in the thumbnail. So please watch the video till last so that you can understand the concept clearly. And please don't forget to subscribe my channels if you are new to. So my dear friends, today we will discuss about the flanged beam. We have already covered the singly reinforced, doubly reinforced and the many more. So if you have not gone through that one, please go and watch the video so that you can understand this concept very clearly. So without wasting our time, let's understand the flanged beam, right? Means flanged beam, right, means where it is seams, right? First questions, right, where it is seams, does it really seams in means structures? Yes, my dear friends, it seems. So let me show you one figure so that it can be very easy to understand. Well, observe these figures clearly. As you can see, this is means what we call residential building or any buildings. As you can see, this one is beam, right, my dear friends. This one is a beam, and at the same time, this one is slab, right. This one is slab, as you can see, and at the same time, this one is beam. So what happens here? This beam and these slabs are means tied each others, right. We can say that this slab as well as this beam is constructed monolithically, right. So such type of means and you can see this one is the structures of T, right. This the upper portion, or we can say it the slab, and the slab is in form of means flange. At the same time, this is in form of T. So this is nothing but the T beam. At the same time, if you observe the slab at the corner, right, so here the formations of L beam, L shapes of beam takes place. So this one is nothing but the, we can say that, flange type of beam. So the flange type of beam consists of T and L, right. Mostly the flange type of beam is T and L type of sections, and in actual practice the slabs and beams are constructed monolithically, right. Means slabs and beams are tied each others, or it is constructed means what you call means jointly. Then there is a formations, or there is a demarcations between the beams and slabs. That demarcations is nothing but the flanged beam. So the flanged, hope you understand the flange. So let's see the flange beam more deeply so that you can understand. So my dear friends, assume that this one is slab, right, means we can see this one, that means top view. Suppose this one is the top view of slab. Just imagine means your chat, right, means your slab. So this one is the top beam, and means a top slabs, top view of the slab. So this one is the length of slab, as well as this one the width of slab. So here means we provided a beam, right, at the corners, right, at the mid of the span, at the corners, right. There may be much more beam as per the required, but here for the means understanding purpose, I have kept one beam, right. This one is one beam at the corner, and this one is the two beam. Similarly, this one is the last beam, third beam. So hope you understand these figures. Means you can imagine these ones very easily. Yes, this figure, the figure which I have shown you, the based on this ones. This one is the means upper portion of chat, or we can say the slab, right. And this one is the mid span beam. This one is the means what is corner beam, and this one is also corner beam. So here the formation of L shaped. So this is known as L beam. Similarly, this one is known as T beam because it is in the form of T. Similarly, this one is L beam. So this one is the mid span beam. So let's see once again. So hope you understand this one. So the length of means from center of these beams to center of this beam is L1. Similarly, the center of this beam to center of this one is means L2. So the means what we call the width of the wave. This one is wave, that is WB. WB is nothing but the width of the wave. So width of the wave is this ones. At the same times, if you need to calculate this area, then it is nothing but the L by 2, right. Similarly, this one is also means L2 by 2 because the total is L2. Similarly, this one's portion will be means L2 by 2. So from these ones, I have shown you the figures like these ones. Sorry, wait, my dear friends. From these figures, right, as you can see, the formation of the middle beam, right, the intermediate beam form any intermediate beams, there may be the multiple beams, that beam forms T sections and the corner beam forms L section. So that's why the mid span beam formation is T beam, its width is, actual width is B, right, and this one's formation of the L beam, right, this one is L beam and the corner is also L beam. So this one's actual width, right, B. So B is nothing but L1 by 2 plus this one, that is here to here is L1 by how much, L1 by 2. Similarly this is BW and this one is L2 by 2. So B is equal to L1 by 2 plus BW plus L2 by 2. But what happens in the flanged beam, actual width is not taken into considerations. Remember that point always, that actual width is not taken into consideration at any point. So we have to remember these points. Always we have to take effective width of flange. This is why, because I will tell you the reasons, right. So let's understand this concept more deeply. Here as you can see, what I did, I have just drawn the above T sections here. So the actual width, this one is B, right, and this one is wave, that is WB. I have reinforced, right, the 3 numbers of bar at the bottoms, right, and from the topmost fiber to the mid of the reinforcement is what we call effective depth, and this one is the gross depth. So what happens, just imagine, suppose this one is a beam, right. So this, if it is beam, if I applied the load here, right, what you call, if you applied heavy load here, then there is a chances of failure, right. Are you getting my point? There is a chances of failure. So if I applied the load here at the what you call at the corner, then there is a chances of failure because the supports is here not given, right. So what we do we neglect the actual width, right. We neglect the actual width of the beam, and in order to prevent from the failure, we consider the effective width of beam. So in every design as well as analysis of the flanged beam, we must consider the effective, remember, effective width only. So what happens, the effective width is till here, right, to here, right. So the effective, if we consider effective width, there is a less chances of failure. So this is why we consider the effective width only in the T beam sections. So let's from the IS code book 456, right, if you go in the page number 36, right, if you go in the page number 36, then there will be a formula given for the isolated T beam, right, for the continuous T beam. So for the isolated isolated T beam, the what you call effective depth formula is LO by B plus 4 plus BW. Hope you know BW. BW is nothing but the width of wave, right. This one, right, this one is the BW, right, this one it is the width of wave. So here the 4 is constant and B is the actual width of width of flange. Here the LO is what? LO is nothing but the effective length of beam, right, effective length of beam. Let me show you the first figure so that you can understand, right. So my dear friends, these ones from here to here, right, mid spans of these ones to these ones is nothing but the LO, right, LO, the effective length of the beam. So it is LO from the above figure, or we can also say the distance between the points of zero movement in the beam. So the zero movement of the beam is indicated as the distance between two zero movement in the beam can be indicated as an LO. And hope you know, as engineers you must know what do you mean by zero moment. You have well concept idea about these ones. So for the isolated T beam, and let's understand what do you mean by isolated T beam, right. So my dear friends, before that let me show you a figure. Yes, this figure is from the side. As you can see, there this one is nothing but the beam, right, and this one is slab. So while we are concreting these ones, right, while we are casting the what you call slab, we cast the slab and this beam at a time, right, and that we construct the slabs and these beams, or we are casting these two things at a time. So this is called flanged beam, or this is so called monolithicals. But what we do, if we construct separately, right, the beam, the first we will cast the beam, later we will cast the slab. So we will construct what you call separately. So such type of beam is known as isolated T beam, right? Means the construction of slab and means what we call beam is separately. So such type of beam is known as isolated beam. And for the means isolated L beam, just here 0.5 LO, right? And means same formula, right? Means LO by B plus 4 and BW, hope you know BW, width of weave, means right, LO is the effective, width means length of the beam. So for the continuous beam, for the continuous LO by 6 plus BW by 6 DF. DF is the width, means what you call depth of flange. So here means these ones from here to here is the what you call DF, that is depth of flange. So depth of flange we have taken from here. So for the continuous L beam, LO by 12, just instead of 6 it will be 12 plus BW plus 3 DF. So all these formula are given in the IS codebook 456 2000s in the page number 36 itself. So from these lectures what I would like to convince is, for the analysis as well as design of the means what we call flanged beam, we will always consider the effective width of the or the effective length or width of the flange, not the actual width, because I have to means I have already introduced or I have already told you the reasons behind it, right? Simply imagine if you means what you call if you make your hand straight, right? Means simply make your hand straight, and means if any load is given on your shoulders, then you can easily withstand. Then continuously if the load is means giving on your means away from the shoulder, right, then what happens, your hand will be deflecting, right? As means as your hand will be, suppose imagines this one's is you, right, and it is means what you call your hand. Suppose if I give you load on this point, right, means on your palm, then what happens, means you can't withstand the load, right? So it will be deflect, right, and it will be deflect in these shapes, right? It will be deflect in these shapes. So if I give you the load here, so that you can withstand easily. So that's why for preventing from these deflections, right, so for preventing from these failures, we always consider the effective width of the flange only. So thank you my dear friends for watching video, right? So please don't forget to share it to your friends. So thank you.